Hello everyone, welcome to Cambridge Guru. Today I have come up with some special video. Why I'm calling this a special video? Because I will be solving some numericals, some questions which are based on chapter number 1, unit 1 which is algebra, and unit 2 which is logarithm and exponentials. If you have gone through some past papers, you must have realized that questions in the final exam, they come as a combination of unit 1 and unit 2. What I mean to say that suppose you take an example of any modulus inequality, it will ask to solve some modulus inequality, but in the second part, it will give you, it will replace the variable x and y with some another variable which is in the exponent, right? So in the subsequent portions of that very part 1 question, there will be some part 2 and part 3. In those questions, you have to apply rules of logarithm and exponentials. Another example could be that it will give you some polynomials. You have to factorize that polynomial and then hence solving some cubic equation. But in the third part, it could ask for solving the cubic equation by replacing the variable x with an exponential variable or any logarithmic variable. Okay, so what I mean to say that combination of chapter number 1 and chapter 2 is very much necessary, and you must be well versed with how to solve these kind of questions. Okay, an important thing for this is that from today I have started my Telegram channel also, and whatever I will do in this video, that will be uploaded on my Telegram channel. The whole PDF of the solution that I will do in this lecture will also be available on Telegram, and the soft copy of the original assignment is also uploaded on Telegram. So without wasting any time, just subscribe my Telegram channel with the same name, which is Cambridge Group. Okay, so let us start our new, you can say, video, special type of video, which is solving the assignment on algebra. So here is our question number 1. It says that we have to solve the inequality 2x minus 5 modulus is greater than 3 times 2x plus 1 modulus. So as I told you in the lecture, I will just give a brief idea about the question, how to solve these questions, although we have done so many theory and I think almost 2 to 3 questions on each and every topic to solve these kind of questions. So the method is we will square both the side in order to remove the inequalities. So let us square this solution. So after squaring, I am just writing it straight away. 2x minus 5 whole square is greater than 9 times 2x plus 1 whole square. Okay. Now applying the formula of a minus b whole square, this will be 4x square plus 25 minus 5 into 2 is 10x into 2 is 20x, so minus 20x. This is greater than 9 times 4x square plus 4x plus 1. Okay, a square plus 2ab plus b square. So again, this is 4x square minus 20x plus 25, just rearranging the terms, and this is greater than 9 into 4 is 36x square plus 36x plus 9. Okay, now combining the like terms and transferring all the terms on one side. So if I transfer this 4x square to 36x square, it will be negative. So I'm writing the final equation, which is not equation, final inequality, which is 32x square. This is 36 plus 20 is 56. So plus 56x, and 9 minus 25 is minus 16. This is not greater than, it will be less than 0 because I have transferred all the terms to RHS. Okay. Now I can take 8 outside, or you can say 8 as a common factor. So this will be 4x square plus 7x minus 2 is less than 0. I have a habit of using factorization method to solve any quadratic equation. If it is not factorizable, then we will go for our calculator or the basic formula, the quadratic formula. So this is 4 into 2, which is minus 8, and I think this can be factorized. So this is 4x square plus 8x minus 8. 8 into 1 is 8 and 8 minus 1 is 7. I think you know how to split the middle term. This is 8x minus x minus 2 is less than 0. So this is 4x, x plus 2 minus 1, again x plus 2 less than 0. Okay. So finally, I have two linear factors, 4x minus 1 into x plus 2 less than 0. Okay. Now you have two values, x is equal to minus 2 and 1 by 4. Now I believe that you know how to solve a quadratic inequality because this is a part of our AS levels, right? So just to give you a brief idea that after putting these two linear factors equal to 0, you get two values. One in this case is minus 2 and another is plus 1 by 4. We always keep negative values towards left and positive values or the greater values towards the right. I think means this is your number line, right, where minus 2 will lie towards left of plus 1 by 4, right? So method of solving any quadratic inequality is that you make the coefficient of x in both the linear factors as positive, first of all this, and if it is positive, then we use wavy curve method, that we will start with plus here and write plus minus alternately, right? Why this is plus minus plus, I think this we will cover when we will do AS levels, right? So solution for this, since it is asking for less than 0, I can say that less than 0 is lying between minus 2 and 1 by 4. So here x is just lying between 1 by 4 and minus 2. Okay, this is your final answer. Okay. Now my suggestion here is, which I forget to mention you initially, that whenever you see this question and in the subsequent question, you just pause the video and try to solve the question by yourself, then see the solution or the final answer, right? I think this will be more helpful to you. So let us quickly, and one more thing, this video is going to be very long, not very long. I will try to, there are total 7 or 8 questions and we will try to solve this within half an hour. So just bear with me. If you are interested in this, just keep your food, your water or any kind of refreshments with you because you are going to need that. Okay. So let us come to next question, question number 2. It says that the polynomial this, where a and b are constants, is denoted by px. It is given that x plus 1 is a factor of px, and when px is divided by 2x plus 1, the remainder is 1. Now as you can see here that in a polynomial there are two given variables, so in order to find out these two values, two conditions will be given. So one condition is given that x plus 1 is a factor of px. So if any linear factor x of the type x plus 1 is a factor of px, then putting x plus 1 equal to 0, you will say that x equal to minus 1. If you put x equal to minus 1 in the polynomial px, you will get value as 0. That is a part of or the meaning of factor theorem. Okay, so if I write solution, px is 8x cube plus a x square plus bx minus 1, right? So x plus 1 is equal to 0. That means x equal to minus 1. This was the method that I told you in our lecture. So x equal to minus 1. So you put p of minus 1, you will get value as 0, right? I can write the reason here that from factor theorem I am saying this. Okay, it is always helpful for the examiner if he is checking that why you are saying that p of minus 1 is equal to 0. Okay, so p of minus 1 is 0, so put in place of x value of x as minus 1. Okay, so that means 8 of minus 1 cube plus a times minus 1 square plus b times minus 1 and minus 1, this must be equal to 0. This is your value of p minus 1. So this is minus 8 plus a minus b minus 1 is equal to 0. That means a minus b is equal to 9. This is your first equation. Okay, let me write equation number 2 adjacent to this. Now second, it says second condition. Why I'm saying that let me write second equation, because second condition says that when px is divided by 2x plus 1, the remainder is plus 1. So what remainder theorem says that putting the linear factor equal to 0, just like we did in factor theorem, you put x equal to minus half back into px, you will get the value as 1. In factor theorem, that value is 0 because you won't get any remainder, right? You remember that I told you when we were doing remainder and factor theorem, that factor theorem is a special case of a remainder theorem when you get the remainder value as 0. That means that divisor is the factor of the polynomial. Okay, so putting 2x plus 1 equal to 0, you will get value of x as minus half. Okay, so p of minus half must be equal to plus 1 according to remainder theorem. Okay, so quickly put p equal to minus half, x equal to minus half in p x. This is 8 of minus 1 by 2 whole cube plus a times minus 1 by 2 whole square plus b times minus 1 by 2 minus 1. This must be equal to plus 1. Okay, so minus 1 by 2 cube is minus 1 by 8. 8 into minus 1 by 8 is minus 1. This will be plus a by 4. This is minus b over 2. This is again minus 1, and this is equal to plus 1. Minus 1 is minus 2. In the RHS, it will become plus 2 plus 1 is 3. And taking the LCM as 4, you will get 2a minus, not 2a, I'm sorry. This will be a minus 2b upon 4 is equal to 3. Okay, that means a minus 2b is equal to 12. Okay, and I'm writing this here. Okay, so a minus 2b is equal to 12, right? This is your equation number 2. Right, now solving these two equations simultaneously, what I can do here is, I think this is a minus 2b. Yes. Okay, I can subtract equation 1 from 2. Let us subtract equation 2 from 1. Okay, so 1 minus 2, the moment I do this, it will become plus 2b. So plus 2b minus b is just b, right? And 9 minus 12 is minus 3. If b is minus 3, value of a is 6. Okay, so b is minus 3, a is 6. Right, then it says when a and b have these values, we have to factorize px completely. Okay, so when a and b have these values, so now let us define our px, which is 8x cube plus ax square. So px now is 8x cube plus ax square, means 6x square, plus bx, I think. Yes, b value is minus 3, so minus 3x minus 1. Okay, this is your px. Yes, 8x cube plus 6x square minus 2x minus 1, or minus 3x. Yes, so we have to factorize this. Now it says that x plus 1 is one factor of this. Okay, if x plus 1 is one factor, I can write this as x plus 1 multiplied by some quadratic factor. Okay, this has to be a quadratic factor, right? The reason I've told you in the lecture series. If you are having doubt why this has to be quadratic, just go back to see the videos. Okay, so if it now there are two ways to find out this quadratic factor. One is long division method and another one is shortcut method. I will go for shortcut method. Okay, so because there is some time constraint for this video too, so I need a factor of 8x cube. I have already x here, so definitely this factor has to be 8x square. Okay, now let us go for the constant term. Constant is -1, so write this, because this 1 will be multiplied by -1, then only you will get a constant. When constant multiplied by constant, then only you will get a constant. You have one constant as +1, you need total answer as -1, so this has to be multiplied by -1. Okay, now what you need is 6x square or -3x. Okay, either you take the value as -3x or you can take the term as 6x square, whichever way you can get. Okay, means the left term, not left term, but the remaining term will automatically adjust. Okay, so you need 6x square, so already you have here as 8x square. That means you need to take 2x square. Okay, you need to take out 2x square. You will get 2x square only when this x will be multiplied by -2x. Okay, now you can check your answer that you have 8x cube minus 2x square plus 8x square is 6x square. Okay, this we have adjusted. Now let us see that whether this -3x is automatically adjusted or not. So x will be multiplied by -1, that is -x, and this 1 will be multiplied by -2x is -2x. So -2x minus x is -3x. Bingo. Okay, so your factor px, your px is factorized to this quadratic factor. Now can we again factorize this quadratic factor into some linear factors? Let us see that you need the product of 8 and you need the term as -2. Of course, we have two factors, which is 4 and 2. Okay, let us check this. Okay, so 8x square minus 2x minus 1 can be factorized as 4 into 2, so 8x square, and you need -8, that means -4x plus 2x. Okay, -1, you will get -2x here. That means 4x common, you get 2x minus 1 plus 1, 2x minus 1. So 4x plus 1 into 2x minus 1, right? So you can write here that your px now is, let me use some different color, px is now factorized as x plus 1 into 4x plus 1 into 2x minus 1. Okay, again pause the video, do this yourself, and wherever you find any problem, just look at this. Okay, let us move to third question. Solve the equation ln x square plus 4 is equal to 2 ln x plus ln 4. Solution. It involves some log properties, that log a plus log b is log ab, right? Log a plus b is not equal to log a plus log b. Okay, please do not get confused with the properties of logarithm. So in the LHS there is a single log term, on the RHS there are two different log terms. If you need to remove this logarithm, both the terms on both the sides there should be a single log term. Means to say, in the RHS we have to first write the RHS using single log, okay, or in the form of single log. So we have on LHS ln x square plus 4, this is equal to Now you cannot combine 2 ln x plus ln 4, means you cannot write the property of ln a plus ln b is equal to ln ab, because this is not ln a, it is 2 ln x. Okay, that means this 2 has to be raised to the exponent of this x using the property number 3, right, if you remember that. So this is ln x square basically. I can write this 2 in the exponent of x and then ln 4. Okay, that means now I can apply the property log a plus log b is log ab. That means ln 4 x square. In the LHS we have ln x square plus 4 equal to this. Now I can cancel these log from both the sides. This is not the right way to say, right? We cannot cancel log from both the sides. Okay, means it is senseless, it is meaningless, right? We say that if log of something, log of a is equal to log of b, then both numbers a and b must be equal, right? It is not the correct way to say that let us cancel these log from both the sides. No, okay, we cannot do this. So I can directly write that hence this implies x square plus 4 is equal to 4 times x square. Okay, combining the terms as 3x square is equal to 4. That means x is equal to 1 is plus 2 by root 3 and second is minus 2 by root 3, right? And it says that you have to write your answer in exact form, right? You must be noticing that I haven't used calculator till now, right? Please try to write your answer in exact form, no matter it is mentioning in the question. If it is not mentioning, if it says that you have to write the answer up to 3 significant figures, then you will use your calculator. So consider this, that if it is written in the question that you have to mention your answer in exact form, that means you do not have to use the calculator, right? Not means if not in between, but in the final answer. You do not need to find out the decimal value of these exact values, because exact value of root 3 is just root 3. It is not 1.732. This is an approximate value. So now we have two values of x, one is positive, one is negative, right? In logarithm questions or in exponential questions or equations, if you are getting two values of the variable, please check whether both the values are allowed or not. What I mean to say allowed is that as our original question was of logarithm, and we know that domain for logarithm is always positive values, right? Log is not defined for negative values. Okay, that means if you put this x equal to, so I can write this as x equal to minus 2 by root 3 is not allowed as log of x, which is in the original question 2 log x, remember in the RHS. So as ln of minus 2 by root 3 is not defined, and you have to mention this in your exam, right? You have to write this x is equal to 2 by root 3 only, right? I have seen one in one marking scheme, and I was preparing for our examination, means where I am teaching. So I have seen in the marking scheme that it is written as only, right? 1 mark for writing this. So basically it is hidden that you have to reject the other value, right? That reasoning is important, why you are rejecting the other value. So x is equal to just 2 by root 3, right? This is the only solution for this. Fine. Okay. Fourth one, the variables x and y satisfy the relation 3 raised to power y is equal to 4 raised to power 2 minus x. By taking logarithms, show that the graph of y against x is a straight line. State the exact value of the gradient of this line. Okay, so let us solve this. By taking logarithms, that means if it is 3 raised to power y is equal to 4 raised to power 2 minus x, So take the log of this, you will get y ln 3 is equal to 2 minus x. You can take log with any base or just log with e, which is natural log ln. This is 2 minus x ln 4. Okay, so this is y ln 3 is equal to minus x ln 4 plus 2 ln 4, right? That means y is equal to minus x ln 4 by ln 3 plus twice of ln 4 by ln 3, right? Now it says that we have to show that the graph of y against x is a straight line. How we can show that any graph is a straight line? By comparing whatever equation we are getting with the general equation of a straight line, which is y is equal to mx plus c. Okay, so if you can compare that this is the value of m and this is your constant c, right? Hence we can say that since ln 4 upon ln 3 is a constant, because log 4 is one value, log 3 is another value, so this is a kind of a constant, not kind of it is a constant. So log 4 upon log 3 is another constant, and twice of log 4 and log 3 is again another constant. So I'm writing this constant as c, and this, the coefficient of x, is your m. That means this is the slope of the straight line. So I can prove that this is an equation of a straight line, right? You can write, hence it is a straight line. It is a straight line with gradient equal to whatever is the coefficient of x. Coefficient of x is minus ln 4 by ln 3, minus ln 4 by ln 3. Okay, and it was saying that we have to write the answer in the exact form, exact value of the gradient of this line, minus ln 4 by ln 3. Okay, then it says this was your first part, right? Then it says calculate the exact x coordinate of the point of intersection of this line with a line with the equation y is equal to 2x. That means we have to solve the equation of this y equal to whatever we are getting in the first part by the equation y equal to 2x, comparing y and x coordinate, y coordinate of both the equation, solve these two simultaneously. Okay, and this portion I would like you to perform by yourself and write the answer in the comment section, whatever answer you are getting, right? And it says that we have to write the exact x coordinate. If you are able to use a log in the comment section, I don't means it doesn't matter. If you are not able to write your log, so you can write the point value also, right? But try to mention the exact value of x coordinate. And remember, you have to simplify your answer. If you are obtaining 2 log 4 by log 6, that means you have to square this 2 log 4, means log 16 by log 6, and then simplify it further if it is, if it is at all simplified further, can be simplified further. Okay, so I'm moving towards the next question, right? Solve the equation 5 raised to power x minus 1 is equal to 5 raised to power x minus 5, giving your answer correct to 3 significant figures. So let us quickly solve this. As you can see here that exponent, in the exponent we have the variable, so the variable will come to the base, right? You will pull this variable only by applying the log, right? But there is some, you can say some glitch in this, that you cannot directly apply the log on both the sides, right? Why? Because if you apply the log on LHS, it will become x minus 1 log 5, but in RHS there are two terms, 5 raised to power x minus 5. So if you apply log of 5x minus 5 in the bracket, okay, if you do this ln 5 raised to power x minus 5 in the bracket. You cannot separate this because log a minus b is nothing, it is just log a minus b, right? So this 5 raised to power x variable you cannot combine with the variable in the LHS. So what you need to do? Okay, so in these type of questions what you have to do is just transfer the variable on one side. Okay, just transfer, keep the variable as 5 raised to power x, right? So how we can do this? I will write this 5 raised to power x minus 1 as 5 raised to power x upon 5, okay, is equal to 5 raised to power x minus 5. Okay, then transferring this term to RHS and minus 5 to LHS, or just keep 5 raised to power x upon 5 on LHS, just transfer this 5 raised to power x to LHS. Okay, so 5 raised to power x upon 5 minus 5 raised to power x is equal to minus 5, right? Now I can take out 5 raised to power x from both these terms. So 5 raised to power x taking outside, you will get 1 upon 5 minus 1. This 5 raised to power x will be multiplied by minus 1, you will get minus 5 raised to power x. This is equal to minus 5. Now simplifying this, this will be minus 4 by 5. So 5 raised to power x into minus 4 by 5 is equal to minus 5, right? That means 5 raised to power x, minus and minus can cancel each other, is 25 by 4, right? And here I can get by taking now logarithm, because in the RHS there is only now a single term, you can take logarithm, okay, to keep this, to pull this variable from the exponent. So x ln 5 is equal to ln 25 by 4. Okay, so final value of your x is equal to ln 25 by 4 divided by ln 5. Okay, this is your final answer. Okay,